My name is Amar Gowda. With me, I have my colleague Pawan. We both are confidential container product PMs here in Azure. Today, we will talk about how the end-to-end security and the integrity of the container environments and what is measured is going to be critical to achieving your goals, right? We heard a lot about attestation and what is measured, what is not. We'll also show you a demo on what is possible today with Azure offerings in this space. So uh, after being in this journey for 3 years, what we learned in the space of containers is right. Containers run in a shared execution environment. There are multiple daemon sets running as well as other pods running. Not everything is isolated, right? So that brings in one problem. There are container configurations like environment variables, volume mounts, and the whole pod YAML that matters on how the security of the TEE of the environment is going to be critical. On outside of this, I think in some other sessions they were mentioned about there's this whole added software stack that is needed for your containers to execute and behave properly, right? That brings in a larger computing base that you need to trust, right? And even attest. And outside of this, there is also dependency on the host and the host infrastructure, Kubernetes, or even managed serverless offerings. All of that are a set of problems that you look at holistically that are applicable more towards the containers rather than just you running IIS VMs and workloads there. In all of this, it's obvious everybody wants to do a lift and shift, right? So everybody wants to bring a container that they have built already and just run it, right? So these are the problems that are kind of drove us to a path, and we would love to continue to innovate within the community in here. So to achieve the security goals, right? So to achieve the goals and the problems we heard, right? So we need to sandbox and isolate either a container or a pod in a shared environment or a shared host. You need full configuration and software. Every line of code that is loaded, including the container environment, should be measured by the hardware and available for you to attest, right? The another thing is the container configurations. As I said, do matter. For example, you have a SQL Server connection string or a volume mount in your pod YAML or your container configuration. You need to know if someone changed it and can you even trust the system. That becomes critical to clean room scenarios when you're trying to bring multiple parties together. I think there were plenty of other sessions where this was covered on what exactly the environment you can trust. And the extension of it is the immutability. Once you load and you're running, you need to make sure there are no backdoors in a way that can change the configurations that it was loaded with. This is where we call immutable policies or immutability of the pods that were launched. In all of this, right, if you're not transparent and make it auditable for you to feel safe that this is an environment you can truly run highly sensitive workloads, then this thing will not scale to everybody. So I'm just showing a picture on the right that shows about all of this different stack and the layers. And container brings in more layers for you to worry about, or really make sure you feel and you can trust this environment in a whole, right? So that leads us to, all right. So let's bring in attestation and see what should be there, what should not be there. I think it's very loud and clear from everybody that the full trusted computing base should be measured and remotely attestable from any environment, right? Anybody who wants to challenge, show me who you are, the evidence should say everything that is from the hardware, the layer above it, and the OS that runs, operating system that is needed, container runtime, and the platform software that is needed for you to execute. And the last part to it, which is actually your containers, right? This is the containers you authorized, you signed as well, right? Container signatures, as well as the container configuration. So this is the whole package. You want to see this for full verification and evidence, because this is how you could build that strong trust, especially in an environment where you don't directly operate. You have operators and DevOps personnel, or you have offshored your environments for someone else to run, but you are authoring the code and the configurations. So all of these together matter to a data owner or a custodian, that this is a safe environment. They can exchange keys or do some confidential data processing. So I'm showing you an example of how we try to achieve this, and how we can show you an example and a real working demo of how we put the container instances for our fully managed serverless PaaS offering. And we are very transparent about what is in your TCB, and will continue to make efforts to open source, if not everything already should be open source. Let's do an example here, right? So what we see here is just a report, raw AMD. These are all the that you see. The fields that matter for configure containers, and which how we have leveraged and extended the capability, is the host data and the report data. So the report data really holds the OS, the tiny optimized container OS, the measurements of it. It's a enlightened SNP Linux kernel with direct Linux boot. So there is no HCL firmware or other stuff that is not measured, right? So everything else is measured. And you have the host data, where we extend the containers and the container configurations and the environment that was loaded as a step two, because the VMs come up first and then the containers come up next, right? That's a layer. So we capture that second layer and we reflect it in the host data. So here is a raw SNP report. You could use, I'm showing a Microsoft Azure attestation that is attesting all of these, but you could feel free to use any tools you like and any attestation service you like to just fetch an SNP report, present it, get it certified that this is true, and you can verify the hash measurements like you saw in the previous session, and exactly attest. I say I can now trust the environment and to exactly run. So this is an example of how we take a full attestation and reflect everything that is part of your TCB uh, getting measured, and you have the ability to remotely attest. So this takes me to the next slide about a product and an offering, how we have achieved this. And this is the demo we want to show you. Pawan is going to walk us through a few scenarios where you could see how a bad actor can tamper something, but how you can identify that the tampered thing is reflected in an attestation report. So just setting the stage here, container Azure Container Instances is a fully managed UK serverless offering. Uh, you get very high isolation per container group or per pod construct in the world of Kubernetes. It is fully isolated. Every container groups gets its own AMD CVSNP memory encryption keys and a TE dedicated for you, right? You could extend the protection by what we call as authoring the confidential computing enforcement policies, where you dictate what exactly has to run in this environment, so that you put the operator out of the trust, right? Anything, for example, gets injected into your boot path, the policies will reject it, right? It says, well, this was not authored, so the container is behaving differently. A layer in the container does not match the hash I was expecting, and the policy rejects it, right? So you'll see all of this in action in a few minutes from now. And the last part of it is the remote attestation, obviously, right? So this is how you should be able to remotely verify everything that you have launched. And attestation here is not a must. It's a thing that you can invoke or build sidecars. We have a model where we have built this as a sidecar, where you can just throw in a sidecar, open source sidecar, to do all of the heavy lifting of attestation and even secure key release, which is another functionality of Azure Key Vault, to do all of this for you. So we focus on lowering the bar for entry by just doing a lift and shift. Everything else is plug and play. You can add and extend. So how we done this with ACI, right? How did we approach this, right? Here's an example. So you deploy a container, right? You say, here is my container and the container configurations that are part of it, made of layers. We create DM Verity read-only disks in the host. So you have authored a policy with that. You'll see an example of the policy in the demo. Yeah, and the policy is basically a hash of your container and container configuration. That's what it is. And the policies are sent at the time of the boot for a tiny utility virtual machine, which is AMD CVSNP protected. And these get reflected there and re-verified through a DM verity, rehash it, right? So we try to do a one-way hash of this to exactly measure if we get to the left side matches the right side, and then we are unblocked to run this. So we attach the disks, then we verify the policy, and we basically boot. Anything that it fails, it will stop and say, I could not verify to the policy to what I was expecting, and I will fail. And these both are extended in your hardware report, right? So this is how things work with ACI today. So where does this lead us to, right? That's a key question here, right? So how do we define the boundaries? So how do we define what confidential container should be, right? So this is how we feel based on a lot of customers we talked to and we learned along, right? The, the the base or where the environment is running should be transparent and fully auditable, be it open source. Open source is always the first thing, but anything else, right? Now, what is part of it? What's not part of it, right? Be open about it. Reproducible. So you should be able to exactly reproduce the full OS, the container OS, and everything else of the runtime to get the same measurement, so you can feel safe that this is the environment that Azure is running on behalf. Container and config integrity, I think we spoke about it. Immutable, right? Once it's launched, if you want to relaunch a new pod, you can't just change the existing pod configuration. You have to launch a new pod and author a policy saying that you trust to make this change. Measure all and attest. That is a fundamental principle of how this whole program is being built on. Smallest possible TCP, right? Let's strip down the things to bare minimum. This also includes, for example, hardening the Kubernetes API or the kubelet interfaces to a run C environment or a container D. We have to go back and challenge, does it need so much of access, right? Can we pull it down and go bare minimum, but still report back to Kubernetes that whatever it needs to know to either scale or monitor or heartbeat. So there are a lot of avenues where we can innovate and work with the community to achieve the goals. I think the a hardened environment and lockdown access, right? End of the day, you want to feel that your workloads are safe from the host attacks as well as safe from operator access, right? So that's the end goal. How are we going to do this? Not alone, right? So we will work with CCC to define this and move this. We are also actively contributing in Kata confidential container space as we speak. We are bringing the concepts of policies and integrity and attestation. And we also plan the ACI stuff is already fully open sourced. It's an open GCS engine. So with this, I'll switch over to Pawan to cover on what the demo will and showcase all of this end to end. Pawan?
Perfect. Thank you, Amar. So as Amar mentioned, I'll be focusing the demo on our latest public preview offering, which is Azure confidential containers on Azure container instances. So it'll cover a few scenarios. So it's going to be one long demo with several scenarios embedded in it. So the first one will be deploying a confidential container group on ECI with a verifiable execution policy that Amar was talking about. And we're also going to leverage the open source sidecars to retrieve a remote attestation from this container group. Secondly, we'll show an error scenario where we will cause a deployment to fail by an unauthorized container, which is not allowed by the policy that was calculated in the first step. We'll also show how we're denying access to an interactive shell into the container by policy as well. And lastly, we'll show how changes to the container image and metadata are reflected in a remote attestation. So we'll drive straight into the demo. So I'll drive this demo using a Python notebook. So let me just quickly start this. So the first step is building and deploying the container image. So I have a very simple container that has that takes in the sum of that takes in two numbers and calculates the sum of them. And then we also have the security policy generation, where we are essentially generating the security policy for this container group and then we'll deploy that onto an ACI instance. And you can see that I have the hash of a security policy embedded in there. So I'm going to take, for the next step, I'm going to take the public IP of the container group and plug it into the Jupyter notebook to get the attestation token. So you can see that I have the attestation token, and I've retrieved the host data from the attestation token here, and it matches the hash of the security policy above. So we're doing this using the open source containers. And I'll quickly stop this container group to sort of walk through the next scenario. So the next scenario is an error scenario here. What we're going to do is we're going to build a new container. Instead of doing the sum of two numbers, it's going to do the product of two numbers. And we're going to push it to the same repository and tag as what was used in the initial ARM template. So once we do this, if you remember, I stopped the container group in the previous step. We're going to go quickly and going to start the container group again. So what this should do is the container group, the ACI control plane will try to retrieve the container, the latest container from the registry, but it should fail because the measurements and hash of the images are different than what were calculated in the initial policy deployment. So while this is happening, we can also quickly
Pawan, can you also zoom in
walk
a
through.
little bit as well, so the text is super clear?
Okay. Uh, yeah. So is this better?
Yes, thank you.
Okay, perfect. So this is the ARM used for the deployment of the sorry, my bad. Sorry, once me go to that scenario again so that I can pause and zoom in. There we go. So this is the ARM template. So while that is deploying, so this is the ARM template that was used for the deployment. So you can see that this is very similar to, if you're experienced with ACI, this is very similar to the current ACI deployment with a few changes. So you can see that we have a new SKU introduced, which is the confidential SKU. And we also have the CCE policy that we talked about in the first step. So these are the few changes that we have introduced to the container group to the container deployment here. So once we go forward, so this is the ARM template. So let's just go back to the deployment that we've started again to showcase the error scenario. So here you can see that we have failed the deployments because the container images have changed. The policy approves only a select list of containers to be deployed into the container group. But because we have updated the container image and not changed the policy and not redeployed it with the policy, while the container group is being brought up, the image deployment will fail. So this is the next scenario. We will try and uh, do a standard deployment with the second. So in the next scenario, we are just going to correct this error scenario. We are going to calculate the hash of the product container and then have it as part of the deployment. So this should ensure that the container group now has the right policy associated with it. And while this is deploying, let's quickly see the scenario where we deny exec or an interactive shell into the containers running in the container group. So if you're familiar with how ACI works, if you go to the running containers on the pod through CLI, you should be able to go interact into the shell and SSH into it. But for confidential containers on ACI, we are disabling this by default. So you try to connect to it, and the error message would list out that exec into this container is denied by policy. So we get a error saying that by policy you won't be allowed to exec into the container and run an interactive shell. So this scenario is something that we have enabled by default. So if you want an interactive shell, you have to enable it, and it'll be reflect in the policy that you have enabled an interactive shell. So the new container has now been deployed. So you can see that we have a new hash of that security policy, which reflects the product template, product container. Uh, so we'll do the similar thing. We'll get the public IP of the container group and slot that into the Jupyter notebook to get the attestation token that is associated with this new deployment. So we plug that. We see that when we open, it reflects what was generated in the previous in the deployment, but the assumption here is that the client is still looking for that sum container, even though we are able to do a new deployment, go through the pipeline and calculate the policy. The attestation that we receive from the container group will not match what the client expects as part of as before it releases its super secret numbers to calculate the sum of two numbers. So these are the four scenarios that we wanted to quickly showcase. So this is all possible today with our public preview of confidential containers on ACI. So we just to reiterate, we showed that you could deploy a container with minimal changes or no changes by calc and add an additional verifiable policy. We also show that we are able to deny a loading of containers that are not allowed by policy and also reflect the changes to the container and catch that on the client side via remote attestation. So that was the demo that we wanted to show. So I think next up is questions. Unless Amar, you want to add anything else to the demo?
No, we are open for questions. We do have a long roadmap ahead of us to allow, for example, policy signing as well, which you could reflect and see in attestation.